All right. So this problem is pretty tricky. It's pretty involved. And it's just like the one on the test. So I would make sure you pay attention on how to do it. What? It'll have two of these, and then a couple other short math ones, and some multiple choice. What? Probably, unless I get quarantined between now and Friday. They'll come in. It was from an earlier class. I assume they'd already be here, but apparently they haven't discovered them. All right. So if you would, I did this problem on paper so I'd have all the math so we could go a little faster. Oh. All right. The test question is exactly like this. So please make sure that you understand it. So I believe we were on letter C, correct? Okay, let me turn the fan off so I can hear you a little better. My fume hood's had a rough week. I was so heartbroken yesterday, Nisha. It is not okay. That was Derek's chance. All right, here we go. Probably don't need that, but oh well. Okay.
Whoa.
What? Don't even worry about it.
Hey.
Hey, what? What?
I get to know. Yeah, I get to know.
Are we ready?
No.
Okay, sweet. Never.
Whoa.
You're not going to fail? Here we go. Okay, fine. You'll fail. All right, letter C. Whoa, why is it a paint bucket? I've never seen that before. It's not cute. It's kind of annoying. Kind of like my children, though. Okay. Yeah. A and B. Well, here's how you balance it. Do you need a review on that?
No.
Okay, good. All right. Okay, before the reaction, what are the only two chemicals in the flask? Just this and just this. So in order to find the pressure, P equals nRT over V. This is so annoying to me. We plug this in. So I need the moles of CH4. This is on number B still. I need the moles of CH4 and the moles of O. So I had 5 grams of both. So I take 5 divided by 32 for oxygen, 5 divided by 16 for methane. That's what this was right here. Then we ended up with 2.235 or 234. Is that about right? For one of them. And the other one was 0.156. Is that correct?
Yeah.
Okay. 0.468. For which one?
For methane is 0.312.
Oh, I'm sorry. I have it. Sorry. 0.234 is when we do the excess later. I'm sorry. 0.3125. And then 0.156. Okay. Sorry. I just had the wrong. I was looking at the wrong thing. That's the 5 over 32 will tell you the moles of O2. 5 over 16 will tell you the moles of CH4. All right, now these must be added together. Because in order to find piv nert, I need the total moles before the reaction. The word before was underlined, right? So make sure you got it. And I never did add them together, so I don't have that answer. All right. This is my total moles at the start, before any reaction happens. So to find pressure, I take 0.4685. That's N. R is 0.0821. And then the temperature was 25, which is 298. Over V was 4. And then we had already done this part, so I did not do it. What was our answer again? 2.86. Okay. So the process to find the total pressure before is to find your total, bless you, moles. That's ugly, but whatever. Oh my, I can't live with that. There we go. Of reactant, and then piv nert it. Find the total moles of your reactant and use piv nert. That is how you find the pressure before the reaction starts. Letter C. What is the mass of the water vapor in the flask at equilibrium? Okay. This one, it tells you what pressure of water vapor you have. At equilibrium means at the end after it was cooled. So it's been cooled to 25. I can now use this to find my moles of H2O vapor. Yeah, you will. So the squiggly isn't just like an equal. It's we're going to do some math to get there. And then to go from moles of water to grams of water, we can just multiply by 18. So far, okay? All right, so this is the pressure, which must be converted to ATM first. All right, so what I need is moles. So if PV equals nRT, then N equals RT over PV. I did that backwards, sorry. Whoops, then N equals PV over RT. We okay with that? Okay, now the pressure, it tells us that this is it. So I need to convert 23.76 divided by 760. Everyone agree with that? 0.03? Okay. Then the volume, it tells me, is 4. Then R. And then T, 298. And I have this number. I get 0.00511. You okay with that? My numbers, I never cleared out of the calculator, so they weren't rounded or anything, so they might be a little different than yours, but I'm sure they're close enough. All right, now, is that the answer I want? No, that's moles. So that was this part. So then I need to multiply it by 18. So 0.00511 times 18, and I got a pretty small number. I got, that I don't think I ever wrote it down. What is it? Point what?
09.
I know I did that somewhere. Where is it? That's the grams of H2O vapor. So it's the answer to C. What is the mass of water vapor in the flask at equilibrium? It's 0.09 grams. Okay, remember this number right here. It's going to be important. Okay. All right. I'm going to erase pretty quick, so make sure you have that. Okay, can I move on? Sweet. All right, it wants D, which reactant is in excess and how many grams of it remain at equilibrium? All right, so we've done excess reactants before. We had CH4 plus O2 goes to CO2 and H2O. And then we had a 1, a 2, a 1, and a 2. Then CH4, we had 0.3125 moles, right? That was just when we took the 5 and divided it by 16. That was way up here. We did this math already. For O2, I have 0.15625. All right, now it wants to know which one is in excess. Now, a lot of times it asks limiting, so be careful that you read. So it wants to know which one will be excess. So I ask myself, still limiting. I would say I find the smaller of the two values. Is this number 2 times bigger than that number? No, it's 2 times smaller. And that's where we got confused. But we got it now, right? All right, so if the answer is no, that means oxygen is the limiting reactant. So CH4 must be the excess reactant. Yes, Judah.
So we get the 2 times more because of our balancing?
Yes. Whenever you ask this question, that's why the 2 was circled. You apply the coefficients. All right, so the excess reactant is CH4. How many grams of it remain at equilibrium? All right, that's kind of annoying because you need moles more, but whatever. This is from an AP test, so they like to test you. So you simply need to take your initial, and then you're going to subtract your used. Now, if you think about it, your used is in relationship to this number. For every 2 of these you use, you make 1 of these. Or the amount used of CH4 is equal to half of the amount of O2. It's 1/2 as much. Okay, that goes back to chapter 4. We've done limiting reactants almost every chapter. Okay, so I need to divide this number in half, and that will be my used, and that's 0.078. And then I subtract, and I get what?
How did we get to 0.78?
We divided this number in half. Because there's 1 of these to every 2 of these, or it's a 1-to-2 ratio, or it's half. All right, now we subtract, and I got 0.2, it's that number I said earlier, 0.2344. That's moles of CH4 excess. Now, think about this flask, and I'm just going to draw it in a circle. When the reaction happens, I'm going to have whatever my excess reactant is. I'm going to have whatever amount of carbon, that's a plus sign, that doesn't look good. I'm going to have carbon dioxide, and then I'm also going to have water vapor. All right, this number right here, it's not the answer, but it's going to be something we use in the future. So it wants how many grams. So we take this number of CH4 and we multiply it by the mass, which is 12 plus 4, which is 16. And I never typed that in either. 3 point what?
75.
All right, that's CH4 excess. There's 4 H's. The mass of H is 1. All right. We okay with that? So the mass of the excess reactant is 3.75 grams, give or take a tiny bit, but please make sure you have this number. Why is this number going to be important? For the question after says, what's the pressure at equilibrium? In order to know that, we need to know the moles of excess gas. Go ahead.
So during unit 4, when we were trying to find the like excess at the end, did we do it a different way than what we just did, just the dividing in half? Didn't we like have the limiting and then solve or something?
Yeah, when we do it in grams, we have to have grams of everything. So we did a little bit longer picket fence and we just put it in and we had the grams to start and the grams at the end.
So that's all the picket fence.
But in the picket fence, this was in there.
Oh yeah, because the middle two would have just been the dividing.
Right.
Okay.
So since I just skipped that, and I know I did it down here, but usually in Pivner, you'll stick in moles the whole time. Okay, good question. All right, so now in my flask at the end, I know I have at least 0.2344 moles of CO2. I also actually have already calculated the water vapor moles. That was early, or up higher on the paper. It was 0.00511. I don't know why I pointed this at CO2. It's supposed to point there. I'm sorry. Call me out earlier on that. I apologize. All right, so the last thing I need to do is find the amount of CO2 produced, right? We okay with that? Now I just need moles. So the limiting reactant will tell me how many of this I can get, correct? All right, so for every 2 of these I use, I create 1 of these. So once again, the amount of carbon dioxide is equal to half the amount of my limiting reactant, because I will use 2 of it to every 1. So it's the same number, 0.078125 moles of CO2 are produced. Can anyone tell me how many moles of water are produced? 0.156. How did you know that? You're good at math? All right, they have the same coefficient, so it's just this number. Now, am I going to put this number in here?
Yeah, I would have said yes.
Yeah, well, everyone wants to, but that's just, we don't know it's liquid, but most of it must be. Because tell me, at room temperature, what's the state of water? It's a liquid. Now, at room temperature, I've deleted it, but some of it was gas. We already found that. That was 0.00511. Oh, Caitlin, I sense your frustration. I think I know why you're frustrated. Okay, so I don't use this in the picket or the Pivner at all. I'm ready to roll. I have CO2.
Because the liquid doesn't affect the pressure. Is that right?
Right.
Oh.
It's a liquid. Because it's water vapor. We already found the gas.
There's a tiny bit. There's a tiny bit of water vapor that's accounted for right here. Because remember, to find total pressure, I need total moles, and then I plug in Pivner. The moles consist of the 3 gases at equilibrium. Water vapor, which was a super small number. Carbon dioxide, which we used chemistry to figure out. Excess reactant, stoichiometry. Excess reactant, we also use stoichiometry. So I have 3 numbers now. I'm going to take 0.078125. I'm going to add 0.00511, and I'm going to add 0.2344, and I'm going to get a total. I did not do a very good job. Is that 0.3176? Now, this is my total moles. So now I can finally calculate my total pressure. Nisha, where did I lose you?
I don't know, it's something wrong, but I'm not sure where, because I got 0.46 normals, so. I think I added,
Did you remember to divide this number in half?
I don't know. No, you can skip that.
All right, so now I need to know my pressure. PV equals nRT, which means my pressure will be nRT over V, which means I have 0.3176. I have 0.0821. I have 298, and I have 4.
So, for the volume, wouldn't it change because there's like water in there too? Or-
Yeah, it will change a microscopic amount because 18 grams, you don't need to worry about this, but 18 grams of water is equal to 18 milliliters of water. But a mole of water occupies 22.14 liters. So this is 0.018 liters for 1 mole. So the ratio of how much a liquid occupies versus a gas is essentially 0. And it will say on the AP test, it would say, assume the liquid water does not affect the volume. It will say that. Now we could subtract it out. It would be like 0.000 something liters, so it wouldn't make a math difference. Okay, when we plug this in, we end up with a number. 1.94 ATM.
Which part did we get the moles from?
We, N?
Yeah.
That's a tough question to answer because we got it from everywhere. This step,
It was the total.
that's the total. This step came from solving for CO2. This part came from solving for vapor pressure to get moles. This part came from calculating your excess reactant. Now, notice right up here. What does that say? Hard. This is a butt kicker. Go ahead.
So, like in that class, we have like the excess reactant, but then we were just adding the gases together to find a mole.
Yep,
So that's all you have to add together for mole, just the gases. You
just
don't-
the gases. When we do PivNert, we only care about gases.
So it doesn't matter if it was in the like reactant to the product. Is it
Nope.
Any gas?
Any gas at the end, we have to add all of them that are gases. So that's why we had excess reactant. And then most of the product of the liquid was of water was liquid. And then we had the carbon dioxide, which is a gas.
Like why don't we add like O2 or something?
O2,
Yeah.
it was the limiting reactant, so it was 0.
Okay.
It was completely consumed in the reaction. There is no oxygen left in that container. Okay, Judah.
So you went up, you found the total thing for stage 4. You put straight into E and found the pressure. So don't confuse why you use it.
You got to say that all louder.
I was confused about between PivNert. So as soon as whenever you found stage 4 and then you found O2, did you just go straight to E to find the pressure? I was confused why we were finding pressure on that.
The start when we found pressure, it was because we were asked what the pressure was before. So the pressure before came from the oxygen and the methane. So that's why I converted them to moles and then went straight to P. But later I have to figure out, okay, one of these goes to 0. One of these is in excess. And then carbon dioxide is a gas at room temperature, so I had to find the moles of that. Water is a liquid, at room temperature. So I had to find the moles of it from its vapor pressure. All right, now bonus. After the reaction, is there any liquid water remaining in the flask? Absolutely, a ton. So to find this out, I'm going to erase stuff, but I'll need your numbers here. To find this out, we find the moles of H2O in the product. And we did that math. Just it was 0.15625, right? And then to know how much of it's liquid, we then subtract the moles of water that's a gas, which is the vapor. That's the point. No, I think that was the 0.00511. The 0.09 was when it was in grams.
Oh, yeah.
15 what? Okay, now this is moles of H2O liquid
So then you can
that I multiply by 18. And where did I get that one? Is that 2.7? What's that? Well, piece of cake. I can tell by body language, you guys are about as lost on any problem we've ever done in our lives. Yes.
Wouldn't you get like that, like wouldn't the volume of the flask change, like the volume of the gas in the flask? Wouldn't it change?
No, because it will throw in a word. I guess this one did it, but it's a glass flask. On the, if it would say a rigid, so this, the volume of the thing will not change.
Some of that space is now just being taken up by the water, so the pressure
Well,
of the
that's
flask-
she asked that same question 5 minutes ago. The fraction is almost zero. So let's do it real fast, actually.
like the density, like vapor is really close to solid, like with the water.
The volume of gas versus the volume of a solid is a huge ratio difference. Just, we can do it real quick. Someone take this number right here and times it by, well, we did it, sorry. So this is 2.71 milliliters of water. So if I take 4 liters, I subtract 2.71, I get 3897.29, right?
Yeah. No, 3997.
Oh, 39, yeah, sorry, 9. So if we went back, so it'd be 3.99729. If we go back and use this as our volume, which I've erased, here I can do it. You just, yeah, you ignore the volume change due to water.
It's like less than a 1%.
Hold on, I'll get it.
Basically, when you find the like the pressure of the gas, like would you like not account for water because it's a liquid now?
You don't account for the liquid water, just
The vapor pressure.
the vapor pressure. Okay, we got before 1.94. It's now 1.939. So it was 1,000th difference. So it's like it's a thing, but it's not one we got to worry about. Are you serious? I don't know. I just don't feel like it's gone very well.
Actually, I got the small one. I feel very poor. It kind of fell apart on the after. Like I got everything
Okay.
right, and then I made it go home and
I got everything else.
But it makes sense.
Okay, well, we better, we're gonna waste a whole hour on it, but I guess we better. It's on your test. Oh, I don't want that. Here we go. I'm just gonna get rid of these.
You know what I mean? $10 an hour. Oh, you could be a CNA, but that's.
Do you feel like you got it 100%?
Heck no. I can get really close. As a CNA, you have to. Get paid for it.
Yep, there we go.
Well, it's the same problem as.
We can vote. Do you not want to do another problem?
No, I just.
Because I can grade based on attitude, and we're going to get less than 10% right. No, I'm not saying a bad attitude. I should say based on how I feel collectively. You understood that. I think you're all screwed.
Yeah.
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 Okay, so give this a try. Oh, did I cross the volume out? Yeah. What's your favorite number between 1 and 5? 3 it is.
There's some really rough vibes in here right now.
Yep. I'm angry myself. Oh man, I'm not. I just know we're clawing behind. And then I'm going to be blunt because that's just who I am. Some of you are asking questions that are exposing extreme lack of understanding from months ago. Like, I won't say the 2 questions, but I'm nervous. I don't know that there's been a lot of maintaining of really important concepts. Oh, I like you guys way more, and I think you're way more focused. Yep, last year they all walked in and sat down like they owned the place, and they're good kids, but they never wanted to work. They all assumed they were mega geniuses, and we have some of those in here, but most people in here are way more humble and realize, oh dang, I need to do stuff. Now, most of them aren't doing it, but at least they know they need to.
Like that. But at least they're like, I want to work. Okay, it's hard, but I know I need to learn this stuff, and I know I need to watch the videos. I will do the best I will last year.
Vibes?
Yeah.
I don't know. Oh, fives?
Yeah.
Sorry, I thought they said vibes with a V. Ben Blaine got a 5.
Oh, of course you got a 5.
Ben Blaine,
Is he the
Oh,
only
Ben
one?
Blaine got a 5.
yeah.
He was the only one.
Then there was 3 that got 4s. Tate Adams was 1. I can't remember the other 2. John.
So, how are we gonna get the balanced equation since they both?
See, and I'm not trying to pick on you, I promise. But that's the question right there that I, in my chemistry mind, think, oh, we're not doing a good job. You should. I'm sorry, John, that I'm just picking on you right now, but absolutely by January, you should be able to own this. N2 plus H2 goes to NH3. In order to balance it, if there's ever a 3 and a 2 on the same thing, you have to put a 2 in front of the 3 and a 3 in front of the 2, because that makes them both equal 6. That takes care of H, but you just made 2 N's. But hey, life's great because I needed 2 N's. 1, 3, 2. Balancing is a skill that, like, by January, your AP teacher assumes you own that and it's not something we need to study. Now, if you don't, you definitely need to go on. If your goal is to do well on the AP test, you got to go onto YouTube. You got to go to Khan Academy. You need to go to Travis DeWitt, Balancing Equations. He has 30 minutes of it, 3 different lessons and practice problems. You need to go back to the daily plan and go back to chapter 3 and chapter 4 when we spent a ton of time on balancing. If that skill's not there, then fundamentally we got some major issues. Last year was pretty good, honestly, but they cut off the 4 hardest chapters. They didn't even have a test on it.
Just like the AP Bio, they did like stuff from the.
Yeah, when we went soft closure, we were on chapter 14, and they only tested to chapter 12. And 15, 16, 17, and 19 are the hardest chapters. They've already said that colleges have told them they won't ever accept half credit again. So no matter what happens this year, you're taking a full AP test. The colleges are not going to accept chemistry credit. They don't think the kids got it. But I'll tell you, a kid that got a 5 last year, those are amazing kids because they had to review on their own. Like Ben and even the 4s, even the 3s. If you passed, it really was your commitment to study from March till May at your house in your basement. Most kids just threw their hands up and said, "I'm done."
I understand this, but I hate it.
It's just a long process.
Yeah.
It's like 15.
Yeah, there's the answer.
Quick explanation, Davidson.
I have a minute and 10 seconds. Okay, here we go. We balanced it. Then the total pressure, we converted everything into moles, and then we piv nerded it, which was around right here. And then we found the excess by taking the moles that we had and subtracting the moles that were used. Where was that? Oh, right here. I'm so glad I didn't record. This is going to make perfect sense. So we found the used, subtracted from here. I had a little mistake right here. Hey, they didn't have to suffer through that. Then we found the moles of our product. We added the moles of our excess, and then that gave us our total moles, which we then plugged into Pivner, got 39.03, piece of cake. I'm sure that JC loved that clear explanation.
I'm gonna pick this up at the end of the day, Davidson.
All right, sounds good. All right, my friends, that was a ton of fun for me.
Hey, David,
Yes.
if I'd want to practice these, can I